Hi everyone. Our project is about predicting Uber and Lyft prices. As college students, we use Uber and Lyft frequently, and we found that sometimes the two platforms charge different prices under the same situation. Our plan is to use machine learning models to predict Uber and Lyft's prices based on weather and time features. The dataset we are going to use is from Kaggle. It consists of two parts, the cab ride data and weather data. Each of these two datasets has 8 features, and our goal is to predict the price variable based on other features like riding distance and humidity. In order to achieve our goal, we first merge the two datasets by their timestamp value. Afterwards, we split the timestamp feature into 3 subfeatures for a better understanding of how time of the day affects the price. In order to help our regression analysis, we also filled out the NA values in the rank column with zeros and transformed the categorical variables into numerical features. Finally, we normalized our merged dataset with a standard scalar and split the data into Uber and Lyft's respective parts so that we can compare their training and testing results.
For feature selection for Lyft, we first calculated the Pearson correlation and got a heat map to visualize the correlation. We observed that car type, distance, and search multiplier have higher correlations with price. Search multiplier is a variable in Lyft's pricing model that multiplies fares when rider demand is high. Thus, we determined that if we create a decision tree to get what features mainly characterize search multiplier, then we can select these features as the features that influence demand. Using the features that influence demand, together with car type and distance, we were able to select features for Lyft. For Uber, since Uber does not have search multiplier, we only utilized Pearson correlation matrix to select features for Uber. Altogether, we have selected 8 features for both Lyft and Uber. The first 6 features were identical for Lyft and Uber. They were car type, distance, temperature, clouds, wind, and hour, but the last 2 features were different. Then we proceed to model assessment. For both Lyft and Uber dataset, we first did train test split with split size equals 0.3. Then we established 4 models to predict the prices for both Lyft and Uber. They were ridge regression, gradient boosting, decision tree, and random forest. Next, we utilized k-fold cross-validation to perform hyperparameter tuning for each model. Finally, with the optimal hyperparameters obtained, we used test set to calculate test mean squared error and test R2 scores for each model. Here are our results for Lyft's models. As we can see in the rightmost column, all 4 models have test R2 scores between 0.8 and 0.9, and the gradient boosting model performs the best. The results for Uber are very interesting. While the gradient boosting, decision tree, and random forest models performed very good, with R2 scores greater than 0.94. Ridge regression only had a test R2 score of 0.25. We think the reason might be that the relationship between the features and Uber price is not linear.
After building and examining the above-mentioned models, we look into the coefficients and relative importance of the regressors and reached our conclusion on important factors that contribute to the price mechanism of Uber and Lyft. To make it short, we found that price is determined mainly by 2 factors, which are service types such as Uber XL and Uber Pool, and distance. This is consistent for both Uber and Lyft across all models. Previously, we expected that weather and time, such as rush hours, would be a major influence on price. However, our results show that they do not have much an impact. For the next step, we want to continue to optimize our current models as well as further investigate into the causes of the low fitness on linear regression model for Uber. Additionally, we want to build a Uber-Lyft classifier to check if there is enough difference in the price mechanisms to differentiate between the 2 platforms. Since even though our results show that Uber and Lyft rely on a similar set of factors, the price discrepancies still exist in reality. Thanks for listening.